All right, last video of the unit. This one is all about hypotenuse leg. So we're going to finish up this foldable about hypotenuse leg, and you will also need the paper that looks like this for a couple of practice problems as well. All right, so hypotenuse leg, the theorem says this. The theorem says that if I have a hypotenuse in one leg of a right triangle, and I know that those two pieces of information are congruent, then I know that the two triangles are congruent. So last class we talked about how things could not be SSA. The only exception to that is if it is a right triangle. So if it has this little square here, meaning 90 degrees, I can actually have that because it would be hypotenuse leg. So last video, notice I put a little note there. We're going to come back to that when we get to 4-5. So originally we were like, no, it can't be because it's side-side angle. However, since this is a right angle and I have legs congruent and hypotenuse congruent, these are congruent from the hypotenuse leg theorem. Okay, so those are only true if you see a little right triangle symbol. So like if I look here, I have the right triangle. So I have a leg and a hypotenuse. They are congruent, so that is hypotenuse leg. Okay, so here's one. What other piece of information do I need? Well, I have a leg. I know that it's a right triangle. I need the hypotenuse. The hypotenuse is always right across from the right angle. So I need to say that GF is congruent to TS. Okay. This is another one. I know that this line is congruent to itself, so it has to be hypotenuse leg because here's my leg. It's a right angle, and the hypotenuse is the same line. Therefore, it has to be equal to each other. Okay. Same idea here. If this is a right angle, this is also a right angle. The hypotenuse are congruent, and one of the legs are congruent, so they must be congruent. All right, let it switch over to our other sheet and look at how this works. I'm actually not going to go through all three examples because they all work almost identical. All right. So with hypotenuse leg theorem here, I know that the two sides must be equal to one another because they are congruent. And I know that the hypotenuse must be equal to each other. And now I have a system of equations. Yay, Algebra 1. We have not worked on systems, so let's take a look here. Since x is by itself and it is equal to y plus 5, I can replace the second x with y plus 5, and then I have plus 3 equals 3y. Why would I ever want to do that? Because now I only have one variable, which means I can solve. I'm going to subtract y. So 8 equals 2y. I'm going to divide by 2. And then 8 divided by 2 is 4. So 4 equals y. X is going to equal y plus 5. So 4 plus 5. So x equals 9. I've solved for x and I've solved for y. I've gotten the answer, so I'm actually done. But I would like to check my work. So x is 9, and it should be equal to 4 plus 5, because y is 4. Yep, sure enough, 9 is 9. All right, what about x plus 3? Well, x is 9 plus 3 is 12. And then we have 3y here. Well, y was 4, so 3 times 4 is 12. Sure enough, that checks out. We do have equal congruent triangles. All right, try the other two for problems, and don't forget about the around the room activity for practice as well.